we'll discuss about parallel and series of capacitor. But before we go there, let's see an example of when we want to find the energy. We'll see some example when we want to find the energy. Let's say, for example, we have this one. We want to find the energy across the capacitor. Now, to find the energy across the capacitor, we will have to know first the formula. We know energy equal 1 by 2 CV square. We already demonstrated how it comes so far. Now, if I want to energy from this first capacitor, is going to be C1. What I don't have, I have C, but I don't have V1. I don't have the voltage. Now, let me find V1. How can I find the V1? One thing that we have to know, as we see that in DC, capacitor act as open circuit, means that our circuit is going to be like this one. Here is going to be open. Here is going to be open because it is capacitor and we have a DC. So I will finally have this 6 ampere, and we'll have this capacitor will go out, and I will have this one. Now I have 1, 3, 6 here. I have now the V1 is this voltage V1. Here V2 is this one. How can I determine V1? I have 50 volt here. If we see, we'll find that this all resistors are in series. Because this one are in series. Why? Because this one there is no current flow here. Here there is no current flow here. Because they are open. Now I can find the current I. I is going to be 50 multiplied by 1 plus 3 plus 6 is going to be equal 5.5 ampere. Now let's see the current across all these resistors are 5 ampere. If we see V1, this capacitor is in parallel with this resistor, and we know that when components are in parallel, they have the same voltage, means that this V1, the voltage across this capacitor is equal the voltage across this resistor. Why? Because they are parallel. Means that V1, if I want to find the value of V1, I will use Ohm's law. What Ohm's law said that I will have 3 multiplied by 5. I will have 15 kilovolt. Because this K. Now I have 15. Now if I want to find the energy, I will have omega 1 by 2 multiplied by the capacitor, 30 multiplied by 10 minus 6 multiplied by V, 15 square. Now I convert this capacitor to farad, means that my unity, what's remained, or the kilo. Now this one is going to remain in kilojoule. Or if you are not sure, or to convert all of them 10 power 3, to convert all of them in the unit volt, and here in farad. Now I found the omega 1. I found the energy for the first capacitor. Let's see. Now if I want to find V2, to find the energy of the capacitor 2, same formula. 1 by 2. I will have omega 2 1 by 2 multiplied by C2 multiplied by V2 square. C2 I already have 20, but V2, how can I determine V2? V2 is this one. To determine V2, I have 50. I have this one from here. I will have 50 multiplied minus, because the current will flow from here up to this. V2 is this potential here, minus V2 is going to be equal 1 multiplied by 15 multiplied by 5, the current. 50, we can say the potential at this point, the high potential, since the current will start flowing from here, minus the potential at this point, this way it is V2, because this is the ground 0. So 50 minus V2 is going to be the voltage across what? This resistor is going to be equal, from Ohm's law, 1 multiplied by 5. Now I will have V2 equal 50. I will have V2 equal 50 minus 5. 50 minus 5. Now let's see. Why 5? When this one is what? 50 minus this one, it was kilo. So I will have 10 power 3. I will have 50, because this V2 will come here, this minus 5 will come here to find the voltage V2. Now if I found the voltage V2, to find omega 2, just to replace the value of the V2 that I got from here, and I have C2. Just after, from the formula, will determine the value of omega 2 there. Now I already know how can I determine the energy from omega 1 and the energy from the capacitor V2, the energy from the capacitor V2. Now if from here, the main point, we have to know this one. We have to know this one. Now let's see. If I have another example, if you maintain this one, the voltage will be in, I can say 1 kilo, to convert this one to ohms. So it's going to be 10 power 3. So I'll have minus 5, 10 power 3. I'll have it. Now let's see for series and parallel. For series and parallel, let's start for parallel. We have, let's say for example, from here, we have this capacitor, we have this capacitor, we have another capacitor. Let's say for example, this one is C1, this one is C2, this one is C3. I have the currents I have I1, I1, I have I2, and I have I3. Now from the KCL, as we see in the previous video, when I is going to be equal I1 plus I2 plus I3, Now this current is going to be divided by I1, I2 and I3 from Cassel. We already discussed about Cassel in the previous video. Now what's the relation between the current and the voltage? I will have I1 C1 dV dt plus C2 dV by dt plus C3 dV by dt. No need to put V1, V2 because all are in parallel. They have the same voltage. So finally I will have C1 plus C2 plus C3 dV by dt. Because same factor is repeated, I can put in factor. So this one is going to be my equivalent capacitor. Mean that the equivalent capacitor, C equivalent, is going to be equal C1 plus C2 plus C3. Is going to be summation of the capacitor when they are in series. You should not confuse for resistor. For resistor, when they are series are parallel, is not the same one for capacitor. Now let's see now if they are in series. As we see, when it is in series, it will be like the equivalent resistor in parallel. When, let's say for example, I have this circuit, first capacitor, another capacitor, the third capacitor. I have C1 here, C2, C3. I have V. This one has a voltage V1, this one has a voltage V2, this one has a voltage V3. Now from KVL we know that V equal V1 plus V2 plus V3. Now what's the relation between the voltage and the capacitor? We already seen in the previous video. 1 by C1 integration of I d t plus 1 by C2 integration of I dt plus for V3 1 by C3 integration of IT dt. Now no need to say I1, I2, I3. Why? Because the same current will flow. They are in series, same current will flow. The current flow here, the same current flow here, same current flow here. Same currents. Now I will have this one the same, this one the same, same factor is repeated. So I will have 1 by C1 plus 1 by C2, 1 by C3 factor integration of IT dt. Now we'll directly see that this one is going to be the equivalent capacitor. The equivalent capacitor is going to be 1 by C1 1 by C1 plus 1 by C2 plus 1 by C3 when are series. We will realize that this one is the opposite one for resistor. For series it will be this one. When we have only two capacitor, we know from the capacitor for resistor C1 by multiplied by C2, C1 plus C3. Or we have three, we'll use directly this one. If 4, we'll also add 1 by C4. That is when we have capacitor in series and capacitor in parallel. for delta and Y, all are applicable for capacitor. Example of series and parallel of capacitors. We'll see some example. Now let's see this. Let's see, for example, this one. He told us to find the equivalent capacitance, equivalent capacitance. Now, let's see the C equivalent in this circuit. How can we determine? If we'll see this one. These two are what? Are in series. They are in series. When they are series, I can directly know that I will have 20 multiplied by 5 divided by 20 plus 5. I will have let me call this one as C prime. C prime, I will have 20 multiplied by 5 plus 20 plus 5 is going to be 4. Now equal 4. Now these two, the equivalent is 4. This 4, I can draw like this one. This 4 is parallel with this one. So since they are being parallel, I have to add them. I have to add them since they are going to be in parallel. Now I will have 4 plus this 6. I will have 10. This 10 and this 20 is going to be in parallel. I will have 10 plus 20 is going to be 30. Now my C equivalent, this 30 and this 60 will going to be in series because my equivalent circuit will be now this one. It's not a resistor, it's a capacitor. So I will have like this one and this one. So I will have C equivalent here. So I will have 30, since it's going to be in series, multiplied by 60 divided by 30 plus 16 is going to be 20, because I will have 1800 here and I will have 90 here, so it's going to be 20. Now the C equivalence, I got it 20. Let's say another example where we can determine the equivalent. In this example, we'll have we want to find the C equivalence. If we look at this 50 and this 70, they are what? In series. They are in parallel. So let me call it C prime. C prime is the equivalent of this. So I will have this the value of this one, which was 50. So I'll have C equal 50 plus 70. It's going to be 120. This 120 and this 20 are what? In parallel. They are going to be in parallel. No, they are not going to be in parallel. I will have capacitor here. I will have this capacitor here, I will have another capacitor here, and I have another capacitor here. This my 20, here is going to be my 20, here is going to be my 60, here is going to be my 120. Now if we would see this one are what series, since our series I will found the equivalence is going to be 60 multiplied by 120 divided by 60 plus 120. So I will have 60 multiplied by 120 plus 60 plus 120. I will get 40. Now I can come from here to replace these two by 40. Now I will have a new capacitor here, 40. Now if we see this 40 and 20 are what? Are in parallel. When they are in parallel, I will have 20 plus 40 is going to be equal 60. Now this 60 and this 120 are what? I will have C equivalent. I will have this one 120 and this 60. So my C equivalent is going to be, since they will be in series, I will have 120 multiplied by 60 divided by 120 plus 60. So the C equivalence I will have 120 multiplied by 60 divided by 120 plus 60 equal 40. So the equivalent capacitor it is equal 40. So next, when we are determining the equivalent, if it is come for delta or y, the formula that we apply from resistor is the same formula that will convert it to delta to y or y to delta. So thank you for watching this video. Next we'll discuss about injector.